Hey everyone, my name is Jin. I'm a student in Jupyter Lab, and myself and Vassiki are going to give you guys a brief overview of Jupyter, Jupyter Notebook, and also Jupyter Lab. So can we just get like a show of hands up and like how many people actually know about Jupyter or how to use Jupyter? Yeah, pretty much everybody. So this would be quite a breeze, I believe. All right, so let's go on ahead and kind of give you like a brief overview of an introduction to Jupyter Notebooks. Fun fact is that it's actually the name Jupyter Notebook pays homage to Galileo Galilei, who discovered Jupiter moons in 1613, and he documented his observations in his personal notebook. Fast forward, it also pays homage to three different languages: Julia, Python, and R, which were the few core languages that it when it first began, the three core languages that it supported. But now the kind of core value is that it supports multiple languages, so it's not just these three, but also like 40 or more than 40 different programming languages. It was started by Fernando Perez, who also invented IPython, which stands for Interactive Python. This whole project of Interactive Python led to Project Jupyter in 2011, and by 2014 it actually became a spin-off and became a project of its own. So what are Jupyter Notebooks anyway? In short, Jupyter Notebooks is an open source web application that allows you to create and share documents that contain live code, equations, visualizations, and narrative text, and you can pretty much put anything that you can think of into this because it's like a web browser. You can have videos, you can have widgets, you can have images, pretty much everything. But the key is, I believe, that it's a web application, so that really makes a huge difference compared to alternative options. So here's a kind of a basic layout of what you might see when you first open a Jupyter Notebook. And there's a couple of things to kind of point out, which are interesting. On the very top there, you can see that it's being run on Google Chrome, so it could be your browser of choice. It doesn't have to be Chrome, but it could be Safari or Microsoft Edge or whatever you have. But also interesting is that you're navigating to a web address, right? It's an address called localhost, which is your computer, and then you have a port number that's running your Jupyter Notebook instance. Which makes it interesting because you can actually, access a notebook that's not on your computer, but it can also be on a different computer or a computer cluster or a high-performance computing cluster. So you can use like port forwarding and SSH to access a notebook that's not on your laptop, but that's living on a different server, and you can take advantage of like running, of like high memory or high storage. That lives on a different computer, but you can all access that through your web browser on your local laptop. The other thing to point out is that it supports multiple kernels or programming languages. So in this case here, we can see that it's running on Python. And within Python, it's an environment that it created using Python 3.6. But this can easily be an R notebook, or it could be a MATLAB notebook or a Julia notebook. And you can access all these kind of different kernels using Jupyter Notebook. Now we can move into the actual contents of what a notebook is comprised of. And it's mainly comprised of like two different types of cells. And on the top there, we have a markdown cell, which is where you would write like narrative text. You could put images, equations, videos, pretty much anything that you would use to like explain what you're doing. On the bottom, you have some code cells, and you can have snippets of code, chunks of code, like a whole package in there, whichever you might like. And you would run this sequentially or not sequentially, and you can run this using a shift enter. So that's just kind of the basic layout. That this is like an interactive environment where you can run codes, and then you can immediately see the output following the execution of your code. All right, so just kind of overview again that you might be the user there, and then you can access the Jupyter Notebook, the notebook server, from different kinds of browser, whichever you might like. And a notebook server really taps into the different kernels that you might have. So it could be Python, MATLAB, or Julia, any kind of language that you might choose. All right, so what is all this good for? One thing that is really nice is that it can be used to really provide the easy way for other people to replicate what you've done in the past. So this is an example that I got from Fernando Perez himself when he was explaining about Jupyter Notebooks. Here is an article that astronomist wrote about atmospheres, And in their papers, they have like a correlation matrix using some data. And what the authors did was they also published an IPython notebook that basically replicates and recreates all the figures that they used in the paper. So you can teach a class, then you can have a student basically go clone the repo, which is on GitHub, and then they can run all the cells sequentially, and then they can figure out that what the authors exactly did to recreate the results that they have. Another way of sharing is using NV Viewer. So this is a kind of a way that you can visualize your Jupyter notebooks. The Jupyter notebooks files themselves are basically like JSON files. So it's comprised of code. If you open it in raw, which we can do later, it's basically just a bunch of text. But how it is rendered is through Jupyter Notebook or NV Viewer. And what's neat about this is you can go here and then you can submit a link to your IPython notebook that's on GitHub, or it could be a Dropbox link that you have. And what it'll do is it'll basically render the notebook for you so that you can share that link to other people and they can quickly see what you've been doing with that notebook. Other neat things, there's a lot of different kind of interesting examples and tutorials on this website, so definitely go check it out. But one thing that's interesting to point out is that you can write complete books using IPython notebook. So for example, on the bottom there, Python for signal processing. If you click on that, you'll see a series of IPython notebooks where each one is basically a chapter or a sub-chapter within the book. And you can open one of them, and then you can see exactly how they wrote the book together and how what they're doing and what goes into their kind of results. Another good thing about widespread use of Jupyter is that it's being more widely used. For example, this is a screenshot from Kaggle. So Kaggle is a platform where people post tons of data sets. They have competitions on how to build better models. They have data science competitions with money prizes or competing for better predicting models and so forth. And a lot of these are shared through Jupyter Notebook. So someone might try something new, and they would post exactly how they went about it, and then they would clone someone else's Jupyter Notebook and build on that and so forth. And these can all be accessed through your web browser, and all the kind of hard work would actually be done on their cluster. So you don't have to run anything on your laptop. You don't have to load gigabytes and gigabytes of data. Everything can be done on the cloud. Okay, so kind of going back, we'll just kind of go over how notebooks can be interactive, how notebooks can be shared, how you can run multiple languages on notebooks, and we can also kind of look at how notebooks can be customized in the process. And one caveat is that notebooks are very unique and it's very powerful, but it's not the one of its kind. There are kind of other ways people have tried to create this interactive environments. So on the left we have the MATLAB live code base that I'm not too familiar with, but I believe some other people have used it, which kind of tries to replicate a similar environment. And you also have the traditional kind of R Markdown notebook where you can also run snippets of code and then put narratives there and create your story. All right, so for the demo, once you download Jupyter Notebook, it's very easy to run it using just calling Jupyter Notebook. And I believe that there's going to be another session going through installing Jupyter Notebook probably, but maybe it's already installed on the Docker container. So yep. So. Yeah. Perfect. All right. So once you open it, so this is slightly a different layout or color than what it natively is. Natively is just white, but I feel like Vassiki might have customized it a little bit. Yeah. And then if we click on one of the notebooks here, so this is an example notebook, and it's comprised of the different markdown cells, and then we have some code cells, and I can just kind of run through kind of what each one is doing. So on the top here we have the markdown cell, and using markdown, it can accomplish multiple things. You can put tables in there, you can put equations in there, and pretty much anything that you can think of. So for example here, you could have like a table of contents up here. You can have some code blocks so that if you're explaining what exactly in the code that you're doing, you can write that in here. You can insert images, but this can easily be like charts or figures. And if you like explaining it in equations, then you can also write type equations in the markdowns. It's also neat. This is pretty much just like an HTML web application, so you can also just access different websites through the Jupyter Notebook. So here we have the Mine website, and you can almost like navigate to different pages within this iframe here as well. Jupyter is, once again, one of the core values was that it can access multiple languages, it supports multiple languages. So for example here we have a code snippet that just prints out hello mind in Python, but we can easily do this in R as well. So in this case we're loading up the R kernel, or a connection to the R kernel. And then with this double percentage sign R, we're specifying that this is R code. And we're writing print hello mind from R inside of the R code. And these kind of languages can also talk to each other. Oh, sorry. Yeah.
How does how do workspaces work? I mean, all these languages live in kind of the I don't know, 1990s workspace world, right? MATLAB or Python or R, as compared to the old C code world, right?
Mm-hmm.
How do the workspaces work across these object units?
Right. So I believe the question is basically, all of these are like separate applications basically. So for example, like MATLAB, right? You need to have MATLAB installed on your computer before you can access the MATLAB kernel.
Right. So obviously you've got to have the underlying app. Now my question is, let's say under Python I had x equals 6.
Mm-hmm.
Now in R, can I access x?
Yep, exactly. Yep.
There's with caveats. So, yeah, so in general, I would just treat them as if they're completely independent and there's no shared memory or anything across them, except for Python and R, and I'm not sure about Julia. You can actually map things across the environments, which is kind of crazy.
But then if I had like a Python block and then a MATLAB block and then another Python block, are the Python blocks in one workspace and the MATLAB in another?
They're all the same.
They're all
the same, but sometimes if the data format, like if there's no kind of equivalent native data type for across languages, often the kind of Python wrapper for like MATLAB, for example, you have to typecast your NumPy array to like a MATLAB matrix, and then MATLAB can access that same object. It's super cool.
Yeah. Like you can have a MATLAB notebook that's just calling a MATLAB thing, and this is if you're using the magic one where you're calling it from another one, right, Jeremy? That's what the example you're giving.
Yeah. So everything, but to your question though, everything is the same workspace shared across multiple languages. So that's one of the things that makes these super powerful.
Wow. Well, in terms of the variables, though, in some cases you would have to, bring them out of your particular like R environment. So like just because I run like an R code snippet, that doesn't immediately mean that like that variable is going to be available for me in like the Python environment. So in those cases, you're going to have to specify which of the variables you're putting into the environment and you're taking out. So yes, there's an example.
Effectively, there's an it's actually, so that makes sense for a workspace. There's an overarching workspace, and then there are kind of sub workspaces, and you can pass things out of your Python piece into the over workspace that then MATLAB can access.
Yeah.
Yep, exactly.
Okay, that's super cool.
Yeah.
It used to only be the case, and maybe it's gotten better, it used to be only the case with certain ones, you wouldn't, so if you had a big data file, you wouldn't have to replicate it because it could just point to the original across. But maybe I didn't realize you could do it now.
If you change like you could do some stuff in Python, feed it to R for later analysis, get the variable back out, put it in MATLAB, and then take it back out of Python. Like you could just be a polyglot and then write some JavaScript too. There's a percent JavaScript.
Do you really want to get
If you really want to.
Look, behind the scenes, you have a web server that's negotiating between different system processes with different memory. So, like, unless you tell the server, the Jupyter Notebook server, to pass memory between them, they will not share memory by default, right? And so the Python kernel will share memory across the cells. the MATLAB kernel or R kernel will share memory across corresponding MATLAB and R cells. But they're not overlapping memory spaces unless you, so like in Jin's example, if you go to your thing, there's like a -I flag which says pass from Python, sort of like right at the call at the top of 51 there. That I is saying convert the memory space df variable of Python to its native R type.
Gotcha.
But if I update df without reinserting it back into R, they're not like synchronized with each other.
I see.
Yeah.
The MATLAB and Python ones do seem
They
to
do
be synchronized,
Oh, wow.
at least when I've used them. But
Really cool. That makes sense. Okay.
yeah,
maybe
I guess
it's-
I've only used the MATLAB Python interactions, but
So is there like, I'm much more familiar with R Markdown, where you have your like window that basically shows you all your workspace variables. With Jupyter Notebooks, do you have to like type a command to get that figured out?
Right,
Is there a
so,
way?
so there is a command to like, yeah, list all the variables within Notebook, but it's not immediately that kind of environment. And Vassiki will talk about Jupyter last, which also recreates the more like RStudio, R Markdown like environment as well. Yeah, so like just to recap, this is the kind of the architecture, and this basically means that you have your notebook server, and you can access different kind of kernels. So like you could have like a Python instance running, you could have a MATLAB instance running, and like an R instance running, and sometimes it seems like Python and MATLAB could be synchronized in terms of their variables, but in the case of like Python and R, you would have to explicitly state what kind of variables you're putting in and putting out, or taking out of your instances. So here's an example of like how you might be communicating between like a Python kernel and like an R kernel. So here's an example where I'm just creating like a random data set with X variable, Y variable, and some grouping factors. So one of the strong points of R is that it has like a really great stats kind of base. And if you want to take advantage of that, in this case, let's say LMER, like linear mixed effects modeling, then you can send in your data frame that was built in Python with this -I flag, and then you can send in the data frame into your R environment, and then you can call the library linear test inside of R, and then you can run your model, you can print a summary of your model. At the same time, if you want to look at the residuals across the fitted variables, you can save those as a separate variable. But here's the part where you would have to take them out. So this -O flag indicates that you want to take these variables that was in the R instance out back into my Python instance. So you can do that, and then once you're back, you're running code back in Python again, and then you're plotting the fitted values and the residual values back in Python for inspection. Yep, go ahead.
Yeah, so if I want to go back into R, does it store in memory everything that's been done in the past R kernel, or does it forget from kernel? So like I have
Right,
R
right.
and then Python, and I want to go back to R
It'll-
and like call objects from R that I computed in that last cell. Does that do it?
It'll remember, yeah. So it's kind of like, think of it as like a separate R kernel that like is there, but you're just basically accessing it. So if you're like changing variables there, and then in a different cell, if you're accessing that again, then it'll be changed, just like you left it. Yep.
Thanks.
Yep, go ahead.
So, I don't think this would be something super common to do, but like, when you allow access to like a Python variable in the R magic cell, does that make a copy of it into R, or does it open a connection between them such that if you like had a Python variable, modified it in R, then exported it back to Python, did some operation on it, and you had an R cell below that, would the variable in R reflect like the updates that you just made in Python?
No, so it'll make a copy as you, Yep. So like if you make some changes in R, add like a new column or something, unless you take it out of it again and then set it into your Python variable, then that changed variable will just live in your R environment separately. Yep.
So when I pass that data frame from Python to R, how can I make sure that the variable types are correct? Such as
Yep,
categorical?
that's definitely a tricky issue. You have to be careful of that. The easiest way to do that is to just like double check within your R environment. So for instance, like some string variables, you want to treat it as factors, but sometimes it might not go in as factors based on some quirks. So yeah, the best way to do it is just repeat like exactly what you might want to treat that variable type as in your R cell. Okay. Cool. Alright, so this is another example in how you might talk to MATLAB. So once you have a MATLAB version installed, then you can link your MATLAB to, to wherever it is on your computer, which is in Mac, so it'll be like in the applications folder. And then that way you can load this extension, PyMat Bridge, and then this is one way that you can talk to MATLAB from your like Python notebook here. And you would use this RMagic MATLAB, and because this is a MATLAB cell, you need to use the MATLAB syntax. So when you're commenting stuff, you would need to use the percentage sign instead of the pound sign. And once again, as Jeremy mentioned, you don't have to be in a Python environment and use MATLAB. You can actually just build a whole notebook in MATLAB as well. And that way you don't have to write this percentage MATLAB in every single cell.
So actually,
Yeah.
I'm realizing we use a different way of linking Python and MATLAB. There's a MATLAB extension that comes with like MATLAB that gives Python access. So if you do import MATLAB, then like MATLAB.engine allows you to directly call MATLAB commands from Python. And then it'll act just like MATLAB, but you're kind of passing the commands to be executed on MATLAB.
Interesting. And again, I'm assuming that in that case, then if you're changing variables in MATLAB, that'll immediately synchronize and change it in Python as well.
Yeah.
Yeah.
Because otherwise, with this percent syntax, it's exactly the same as your R example earlier with dash I and natural design.
Yep. And kind of the last part is that you can also talk to your system terminal. So in this case, it'll be bash, and you can also use this kind of magic with the percentage bash, and you can access information in your terminal. Or in Python, you can also use this bang sign, and then it'll also immediately access variables or commands in your terminal. Yep.
So are these Jupyter notebooks private or not? Now I'm confused because now we're on servers and we're on the web again.
Mm-hmm.
What kind of mainframe structure, going back to the 1950s, do we actually have now, and what kind of safety issues show up? If this is on some server, then what are the protection issues there?
Right. So it's
Great question.
yeah. So basically, it's running a local server if you're running it on your laptop. So only you have access to it. Often when you run it, for example here, you'll see that it gives you like a token here. So that's kind of like the password in terms of like, what like browsers can actually access the environment or your files. So if you don't have this token, then you can't, even when you're on your browser, you can't access the file basically. But it's been more and more developed, so it doesn't have to be on your local computer. So for example, I can run a Jupyter Notebook instance on like a computing cluster, and then it'll be running there, and then I can forward into that cluster, and then I can try to grab the IP address to that notebook and the port number, and then I can access that notebook from
You can tunnel through SSH, so
Yep.
it's encrypted.
Yep. And then there's like the kind of cloud case where it could be like Google Colabs or like Kaggle's, where you basically have an instance running on the cloud, and it's not your local laptop that has like all the variables or the data, but you just have an instance running on the servers of the companies basically.
And those are also encrypted.
Well, then the system terminal, your bash shell, is running on their servers, not on your laptop.
Exactly. Yep. It'll always reflect the terminal that your server is running on. Yep.
Yeah, but I don't know if everybody knows that, because you can run an interactive, so if you're on your university's local cluster, you can submit an interactive job and start a Jupyter instance, and you can tunnel in, so you're not running it on the head node itself, which is what a lot of people try to do. You can actually run it as if it's a job, interactive job, but from your local computer and accessing it. So anyway, there's something really handy if you'd like to work in this type of environment.
Kind of last kind of demonstration would be kind of using different kind of widgets in the Jupyter notebooks, and this is extremely useful if you want to be more like hands-on and like inspecting your data. So for instance, this is using Bouquet. There's other kind of programs or packages that you can use to create these interactive widgets. But in this case, you can move these slider bars, and it'll immediately change the kind of plots that you have to your right. and you can inspect the different kind of data by clicking on different scatter plot points, and it's just like bringing the data more closer to you when you're using this kind of like an interactive environment. So that's pretty much it. If there's any other questions, I'll just pass it on to Vassiki, who's going to talk about Jupyter Labs. Yep, go ahead.
I have a general question is how you version control notebooks, because they have their own internal thing, but they don't play well if you try to commit them.
Yeah, that's a great question. Yeah. So one of the things is, the reason I'm not necessarily running all these cells right now, because I've created these in my laptop, and then I pushed onto GitHub, and then we downloaded this, we cloned the repository into Vassiki's laptop, right? But for example, Vassiki might not have MATLAB, right? In that case, everything becomes moot because this is the code to run it on my laptop, but then she doesn't necessarily have MATLAB, so the code will break, right? So people have been trying to figure out how to avoid this, and one example is Binder or Docker containers, where you can create like a GitHub repository, and then you'll specify what the requirements are. So I would specify that you would need MATLAB instance for this, you would need to download an R to a Python connection package, and then in those cases, then you can just kind of put that onto the kind of a binder instance, and then when other people access that notebook, they'll have exactly the same environment that you were running your notebook on. So that's one way to kind of control. Yep.
Since you're saving all the outputs in the files, so when you if you just clone a repository, run it, and then you have all the outputs saved, so then you're going to look in your Git status as you have a lot of changes, but it's just that you ran it.
So there's a project called NBDime, which actually integrates with GIF to solve exactly this problem.
Oh, wow.
It intelligently diffs the notebook in the JSON of the code cells and not the outputs. So if you look that up, I think it's under active development, but it's to solve exactly this issue.
Yeah. Right, okay, great.
The solution that I use personally is called Jupyter, if you've ever heard of that. And that's to sidestep the issue entirely by just having your notebooks turn into Python files or Markdown files or whatever. So there's no more issues with that. It's now plain text. Does that make sense?
Or can you go back from text into the...
Yes. So you can edit them either way. So the idea is it makes a mirror representation of the notebook as plain text. And it doesn't have to worry about output the output cells or JSON or anything. It's just plain text. You can edit that as you want and go back to your original notebook even and change it to be reflective. Set it up that way.
Is it called?
Jupyter.
You want to just drop it in Slack. Do we have a channel for
Yeah, this is just another kind of demonstration that Jupyter Notebook, the I, Pi, and B files, they are essentially just made of these JSON kind of strings, indicating this is a cell type markdown. You might still have metadata in terms of when you ran it, and you would have all the text values inside of it. So here's an example of execution time and end time, and it'll hold all the images that you might have run, and this would be an example of an image just encrypted into a text file. Cool. Yep.
So I'll try to spend not too much time on the slides and then actually go and do a demo about Jupyter Lab. So we got a census on how many people use Jupyter Notebooks. I was wondering how many people use Jupyter Lab in their everyday life. Awesome. But as you can see, I think people really latched on to Jupyter Notebooks, got all these fancy extensions, and didn't want to migrate to Jupyter Lab anymore because not all the extensions that work for Jupyter Notebooks work for Jupyter Lab. But it's pretty powerful. Everyone recognizes that Jupyter Notebooks are extremely useful for teaching and for disseminating information to people in the lab, but they're not necessarily very convenient to prototype code. And that's one thing I find Jupyter Notebooks actually very powerful for. When I don't want to put everything on IPython just to see what the data looks like, I actually want to be able to go back to it. I want to save it on a notebook. But then if you just try to map out this whole analysis pipeline, it gets really intractable really fast. And Jupyter Lab basically creates an IDE on the cloud. And when people like research assistants come and ask you, how can I use Python to get familiar with it? Sometimes Jupyter Lab can be the answer to get them started. So I'm just going to walk you through it, and just to kind of set the stage for why these can be pretty awesome, let's try and imagine a world where you didn't spend a lot of time scrolling up and down notebooks when they have 300 code cells in them. Maybe you don't want to waste code cell after code cell trying out what the outputs of a particular function are. You just want to do it on the side. You don't want to like look at the length of the variable and the type in unique code cells and waste that precious space. You might want to deal with other types of files other than IPy and B in the instance that, like you were asking a question about what the workspace variables can be. Maybe you want to look at a project that has a bunch of Jupyter Notebook files, but also has a README to go with it, and you want to look at it and make up your mind about what you want to read next. So you can look at text files in parallel to what code you need, basically. And then if you were just kind of writing a tutorial and you wanted to like upload a README that goes into like details of how you install your module, you might have code chunks in your markdown. And if you just wanted to check it out, if you just wanted to see if it's syntactically correct, if you could just use the power of kernels to try it out rather than just relying on, doing it on the side, just test out whatever you're intending to upload in real time. So those are the kind of powerful things that Jupyter Lab can allow you to do in addition to Jupyter Notebooks. And apart from the extensions that Jin was talking about, like table of contents and all that fancy stuff, most of the things that you can do with Jupyter Notebooks, you can do in Jupyter Labs because they're literally hosting Jupyter Notebooks. In the words of the Jupyter Lab project, it's a next generation web-based user interface for Project Jupyter. I just tend to think of it as an integrated development environment. So this is language from the documentation, which is linked down here, so you can go check it out if you need to. This documentation is also available when you actually open instances of Jupyter Lab, so you can refer to it anytime. But these are the kind of things I want to demonstrate in the next section of this tutorial. So the first is code consoles, which actually allows you to play with the variables in your workspace. You have kernel-backed documents, which I was mentioning earlier. Like, let's say you have a text editor open, like a markdown or just a .txt. You just want to run snippets of code and see if they make sense. You can do that with Jupyter Lab. Then you can also kind of open multiple views of the same notebook. So let's say that I'll show you this in the demo, but let's say that you wrote some code earlier and you want to rewrite a similar function later in your analysis pipeline. Usually you scroll up and then you copy the cell and then you just paste the text in a raw way in the notebook. But what you can do with Jupyter Lab is open two views side by side and actually physically move cells between instances of the notebook, which is extremely convenient. Then you can also, one of the powerful things about Jupyter Notebooks is that you can plot in the document itself, right? What you can do if you have like a bigger plot that you want to look at more closely and maybe zoom in or something, you can open like a view for the output itself, which is very nice. And then you can like edit text files in real time and look at how they're rendering on another instance. And we'll see examples of that as well. So without further ado, I'm just going to open up a pre-existing project. And this is a little bit like airing my dirty laundry, so don't judge me, but I'm doing this for you guys. So I think at least one person in the audience recognizes this folder. So this is something we've been working on with my awesome RA, Rebecca, who's sitting in the audience. And I was initially sharing sort of the Jupyter Notebooks with her to try, but you don't want to limit your analysis to Jupyter notebooks, right? You want to move away from them. You want to script at some point. And because you can have text editors on the side and you can move code around, like it's really useful to be able to prototype with the notebooks and start writing a script in parallel. So not only was I able to share the code from the notebook with her, but also the script later for her to debug. And I'll show you an example of that. So the way to launch Jupyter Lab is very similar to Jupyter Notebook. You just say lab instead of notebook. And automatically, the view that you get is slightly different from what you see with notebooks. Usually notebooks will show you whatever is in the directory from where you launch it. And usually you have like a specific directory for your notebooks and you see the list of what's available to you. Here, not only is it showing you what exists in the directory that you launch Jupyter Lab from, but it's giving you several options for what you can potentially launch. So just let's walk through that a little bit to begin. So you can have a Jupyter Notebook instance with a Python 2 kernel, or for me, I'm just calling my Python 3 kernel hack.myth because that's when I created a virtual environment for Python 3 and never changed it. You can also start like a console. So basically, in the olden days when you used to just do IPython to try things out and import modules and see if they work correctly or not, you can open a console for that on the side, and we'll see the power of that in a moment. And you can like use any kernel that you want for the console as well. And then we have options like a text editor and a terminal. So terminal, like Jin was showing this earlier, you can use the magic commands to start like a bash code cell, but here you can like open the comfortable view of the terminal that like you can navigate in and do whatever you need to. So that's pretty convenient as well. So to begin with, the first thing I want to talk about here is code consoles. I'm going to open up this pre-existing notebook here, get rid of the information about what's in the directory, and just import things that I use on a daily basis, basically. So here what I'm doing is getting PyMVPA functions that we heard about this morning, and then some basic functional dependencies such as OS for combining file paths and NumPy. My intention is to load 2 different types of fMRI datasets and keep them in the workspace. If I was ordinarily using a Jupyter notebook, what I would do is something like, if I wanted to know something about what's in that dataset, how big is it, I would do something like that, and then looking at the dimensions of the data. And this gets like messy really quickly. Maybe a lot more if you're more type A than I am, but I tend to do this a lot, like just looking at variables and seeing what's inside them. What you can do to avoid that is open a new console for notebook. And that basically, so this is going to dump a lot of information. As Yarek said this morning, when you do from MVPA to Suite import everything, you get everything in the workspace in a flat manner. So you're going to get a little bit overwhelmed here. But everything you have available in the notebook actually exists in the console that you just opened for it. So anything that you want to do, like for example, you want to look at what the variable you just loaded is, you can do that on the console, so you don't have to waste precious space in your notebook. So that's kind of an advantage of having consoles on the side. And as you execute more things in the notebook, it becomes available in the console as well. So a good practice is just to have it open on the side. So the question about can you look at the variables, not exactly like RStudio where everything is pretty and on the right hand side, but like it's all available to you. So that's super helpful. The next thing you can do is use kernel backed documents. So let's try and do that here. Let me just open up this markdown file. So this is like copy pasted from markdown cheat sheets. What I can do here is first of all open up a markdown preview, and then I can just move it to the side so I can see it in parallel. And if you guys use overleaf, this might be reminding you a little bit of overleaf. So what I can do here is change the markdown in markdown syntax, but also see what it looks like in real time. So I have already covered code console, so I'm going to check that out, and I know that I'm moving on with the plan for this demo. Another thing you can do, let me get rid of this, is basically open up text files, which are deceptively simple, but then you can write some Python code here and say, okay, I'm going to start a variable and then print its value. You can basically, just as we did for the notebook, you can start a console for the editor, and you can choose the kernel that you want to use for that as well. So this is a text file that you have a console for. If you select the lines that correspond to syntactically correct code, you can actually execute them in the console. So let's say that as I was saying earlier, if your README has code blocks, you can try them out before you push them on GitHub for people to use, for example. And like right now, one thing that's helpful is that I so far have opened this Jupyter notebook, and then I opened this .text file, and they both show this green dot on the side, which means that they have a kernel running in the back. So it's super useful to see that, okay, this .text file is actually not acting just like a text file right now. And like this is working because I chose the Python 2 kernel, but if I was to choose the Python 3 kernel and try to run this line, of course the print syntax isn't valid anymore, so it'll throw an error. So all of that can be leveraged with using kernel-backed documents here in Jupyter Lab. By the way, the only reason this is not in the dark theme, which is available to you, is because if you open up a text file, you can't see the cursor.
They are overrated anyway.
Cursors?
Cognitive state, right? It's not overrated.
You work at an elevated level, right? Okay, so one of the most useful things, again, is like, let's launch this notebook again and get rid of the, change that back to white. What I'm going to do is open a new view for notebook. This is not a console, this is just like the very same notebook in another tab. It takes a little bit of time to launch, but then it's ready to use. So let's say that I started writing code here, and then maybe this is the first time that I tried to set up a searchlight, right? And I tried it, it ran, I know it works, now I want to actually write a function with it. But I had the genius idea of writing a function only very late in the notebook, and I don't want to actually keep scrolling up and down. I just open up two views, and wow, it's far down. See, that's what's useful. Okay, let's just go with this example that I'm running another instance of a searchlight with a different function. So what I can do is just take this cell and literally move it into another view of the notebook. And if you scroll down, oh, I actually moved it on the same place. Let me take another, let's take this block 99 and then move it under this 77. So if I go up to 77 again, it's actually right here. So you do file and then you open new view for notebook. If you were actually, if the only thing on your workspace was a text editor, then it'll say new view for text editor or new console for text editor. And a little bit of a detour, but here you already saw, we can see everything that lives in the directory. You can see what's running, like not just the kernels, but also what terminal sessions I've opened in the past. This is useful. You can look up the shortcuts for navigating in the notebook just as a tab. You can like manipulate what you want the different code block types to be or the cell types to be. And then you can see what's open right now. Another thing I was mentioning earlier is that Jupyter Lab reference is actually available just directly here. So they actually have very useful little YouTube videos that you can check out to, you know, figure out how to do like one small simple function that might be useful. Okay, so that pretty much concludes the demo. If you have any questions about workflow in Jupyter Lab, if you have any questions about what you're losing or gaining with using Jupyter Lab versus Jupyter Notebooks, you can feel free to ask them now. But in general, maybe one thing I can show already before we get into that is how convenient it can be to script sometimes with the Jupyter Notebooks and a text editor on the side. So let's say that a lot of different functionality that I wanted for my searchlight analysis is all out here in the notebook, but I want to be able to run it across multiple subjects. On my high performance cluster, what I can do is just open up like a text editor on the side and look at the content of my cells and be able to start scripting while I have the Jupyter Notebook available, so that I don't postpone it ad infinitum. Like, it's always nice to have a script ready in your little prototyping directory as well. So that's something that I find that, there are absolutely no excuses to keep everything on Jupyter Notebooks forever anymore. Yeah, and I think if you have any questions, you can ask them now, or we can break for coffee.
Since I have an old laptop, this is what I ask often. How much faster does it die compared to, like, do the browsers just die compared to when you're just using the web?
It doesn't happen any faster than Jupyter Notebook for me.
Because for me, it happened more often. It was another reason that I went back to basics.
I think they released Jupyter Lab when it was pretty beta, so I think a lot of people tried it when it just came out and then were turned off by it, but I think they kept working on it and it's a lot better now.
So I saw you opened like the tab with the Jupyter Lab documentation, then you went in your terminal, then you shut down the notebook server, then you restarted it, and then when it opened back up, that tab was still open. Is there some memory that is like persistent between?
I'm not sure. I might not have shut down the kernel entirely as well. Like here, for example, I didn't exit it completely, so it might be that it was just in the stack. But I don't know. It opens the launcher view. When you turn off the kernel and you open Jupyter Lab instances again from the same directory, it opens the launcher that shows you, here are the notebook options, here are the editor options, etc.
One really appealing thing about Jupyter Lab seems to be that you can work together at a distance in the same notebook or in the same interface. Have you tried that, and how can you set that?
When that ends up happening, I tend to use Google Colab more often than anything.
That's a lot better for that.
Yeah. I mean, one thing with Google Colab though is that the kernel dies quite often.
For me, that has survived better because it's actually remote, right? It's not on my local laptop. And the best use of Google Colab for me has been when somebody doesn't have their laptop set up, they have a wrong version of everything, and TensorFlow doesn't work. You just install everything for them on Google Colab, and they can follow the tutorial, and then later they can deal with hours of installing something on their laptop.
Right. I think Brainiac tutorials are pretty powerful for that reason, because everything is available on Google Colab.
Yeah, a lot of things like, I don't know, the deep success representation stuff, and then a lot of them are just on Google Colab, so nobody needs to add extra. Wait, does this have that kind of option, so it's not running locally, or no?
I'm not sure.
Okay.
I don't think so.
I don't think so either.
I think you have to use things like MyBinder to have stuff packaged together with notebooks and modules and data and everything.
That's a surprising use of Google Colab.
Mm-hmm.
By the way, speed in that is a lot higher if you're running simulations.
Oh, really?
Compared to my local, yeah.
So you use like the
Yeah. No, I think there's some limit that you don't need to pay for it.
Oh, that's cool.
And even when you're using your local computer, your local CPUs, if you have, so I've tried it on my lab computer and on this, it runs faster through Google Colab on the lab computer. I don't know, something like in the order of 4 times faster than this. and it runs faster in the Google Colab compared to my Jupyter Notebook. And I think the reason is that they're running things, so some of the time that it takes for running things locally is not consumed anymore. So even when I'm running locally, because the sort of some of the processing is not local, it's much faster. But that, I'm not entirely sure how to optimize it for parallel processing. I haven't tried that in Google Colab, but it seems like for simulations it was very fast.
Do you ever run into privacy issues? You try to run privacy?
Great question. I actually did, because once I was giving a workshop and I wanted to share some things with others, but I didn't want to put it on a GitHub repo and I didn't have everybody's email. I wanted it to be in a way that I can. That became so complicated that I just shared the GitHub repo. So.
Can you use GitHub? Can you use Google? I mean, I haven't used it. Can you use Google Colab with Google Groups? Because at my university, everything's now Google, which is a whole other privacy issue we can talk about offline. But you presumably have Google Groups that you can define shares among.
Interesting.
So you could share it among a Google group that you have control over. I don't know how that plays with Google
Right,
Colab.
that makes sense. I don't know that. Like
So-
if you had a lab or if you had a lab meeting.
I know for Google Docs, for example,
Yeah.
that works extremely well, where you define it, you put a Google Doc on a Google group, and then anyone who has access to that Google group plays on that doc, and it is as private as anything is on the web.
I don't know, because this is not, has anyone shared?
I haven't used Google Groups in the recent past at all, so we can look it up and try to figure out if Colab is more readily shared with Google Groups. I mean, it was developed between teams at Google, so maybe that's the case, but I'm not 100% sure.